242, question 9. A box that holds an expensive pen has square ends, and its length is 13 centimeters longer than its width. The volume of the box is 60 centimeters cubed. Determine the dimensions of the box. Now first you want to start by drawing a rough sketch of your object, which in this case is a box holding an expensive pen. Now in order to best represent this, you want to make your drawing three-dimensional so that it's easier for you to visualize the sides and the volume of the box. Next you want to label the sides. Now you know that it has square ends, so its height and width are going to be the same. Let's call it x. Now the length of the box on all sides, on all four lengths, is going to be the same. And we know it's 13 centimeters longer, so it's x plus 13. Now we are going to write down our height, width, and length. So we know our height is equal to x, our width is equal to x, and our length is x plus 13. So we now need to solve for x. Now we want to find our equation of our volume. So we know that volume is equal to length times width times height. Now we're going to substitute in for our variables. So our volume is 60 centimeters cubed, and that is equal to our height, which is x, times our width, which is x, and our length, which is x plus 13. Now in our next line, we are going to multiply our width and our height together. So we're going to put 1x into x plus 13. So we're going to have x again for our height times x squared plus 13x. Then we're going to multiply the other x into x squared plus 13. So we're going to have 60 is equal to x cubed plus 13x squared. Now we want to bring this 60 over, so we have to subtract it from both sides. So we're left with 0 equals x cubed plus 13x squared minus 60. We need to find the roots of our equation. F at 1 gives us 46. So that does not equal 0, so that means it is not a root. So we write down f of x is equal to x cubed plus 13x plus 0x minus 60. The 0x is there so that we know to include that later on when we are factoring. Now let's try f at 2. So everywhere that there is an x, we will be substituting in 2. Now the reason for this is so that I can use synthetic division to factor my equation. So we are left with f of 2 is equal to 2 cubed plus 13 times 2 squared plus 0 times 2 minus 60. So in our next line, we will solve for all of the solutions. So we get 8 plus 52 minus 60. And that is equal to 0. So that means it is a root. So our root is now x minus 2. And it is minus 2 because it is positive, which means that in the brackets it needs to be negative. The reason we substituted in values for x into our equation was so that we could find the dimensions of our box easily. Now, with synthetic division, you want to write your root outside of your division table, and you want to write down the coefficients of each of your variables. So you have 1, positive 13, 0, and negative 60 from your equation. Now, the first column, always, no matter what, carries down, which means that that answer is 1. Then you want to take your root, which is 2, multiply it by 1, which is your answer, which gives you 2, because 2 times 1 is 2. Then you want to add your 13 and your 2, that gives you 15. Now 2 times 15 is 30. So you want to write 30 underneath your 0. Now you add 0 and 30 and it gives you 30. Now you want to multiply your 2 and your 30, which gives you 60, and write it underneath your negative 60. And then you add 60 to negative 60, that gives you 0, which means you have no remainder. Reasoning behind using synthetic division is so that it helps you to easily factor the previous equation. Now with your answer, you want to add in your variables of x. So you want to start at the right, which is 30, and that always has 0 x's. Then the next one has 1, and the next one is x squared. Now you want to put together your root and your factored equation. You want to put them together to make one equation, which is f of x is equal to bracket x minus 2, close the bracket, times x squared plus 15x plus 30. Now we're going to rewrite our equation, which is f of x equals x minus 2 times x squared plus 15x plus 30, and then close the bracket. Now, looking at this, we can try to factor it to find roots, but there's nothing that can multiply to 30 and add to 15 that will give us our roots. So since that can't be factored, we have to try and use another method, which in this case turns out to be the quadratic formula. Now the reason for using the quadratic formula is because it helps you find the roots of the equation that you have or are given. In our case, finding the roots is important because it will help us determine the dimensions of the box. Now we will write out the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac. And this is all over 2a. So now we'll write our equal sign. Substitute in for b, which is 15, so negative 15 plus or minus the square root of 15 squared minus our minus 4 times 1 times 30. And this is all over 2a. Or 2 times 1. So next equals negative 15 plus or minus the square root of 225 minus 120. That is all over 2. So the next line equals negative 15 plus or minus the square root of 105, because that's 225 minus 120, all over 2. So now we get two answers with this quadratic formula because you have a plus root 105 and a minus root 105. So the first answer would be x equals negative 15 plus the square root of 105, all over 2. When you do that, you get approximately negative 2.3765. And then our second answer would be x equals negative 15 minus root 105 all over or divided by 2. And this answer will give us approximately negative 12.6235. Now, since both of these answers are negative, we know that they cannot be part of the dimensions of our box, as by doing so would not be possible, as you cannot have negative side lengths. Which means in this case, since we only have one positive answer, that we will have to use the root of positive 2 to help us find our side lengths. Okay, so now we know that x must be equal to 2 because it is our only positive root, or 0. This means that wherever there is an x in our height, width, and length, we now make that 2. So our height is now equal to 2 centimeters. And that means we know that our width is also equal to 2 centimeters. And our length is equal to 2 plus 13. So you add 2 and 13, that gives you 15. Now that we have our dimensions, we will now write our therefore statement. Therefore, the dimensions of the box holding the pens is 2 centimeters by 2 centimeters by 15 centimeters.